Okay, so now we're going to start focusing on finding x and y intercepts algebraically, which means that we're going to be given equations. So the first thing I want to talk about is a tie-in to our last lesson that we were doing. Okay, last class I told you guys we were solving linear equations, right? And that's where we had something like 2 equals 3x plus 7. Okay, 2 equals 3x plus 7. And you guys would try to solve that. Your goal was to try and get x by itself. And that actually has a tie-in to what we are doing in this class. Okay, so these were the linear equations that we were talking about last time. This is the linear equations that we were talking about this time. Hopefully you guys recognize this. Y equals mx plus b. Okay, that's how we graph our lines. Okay, and we will cover graphing lines later on here. But right now I want you guys to know that this is actually the same thing as this here. Okay, I just have to do a little bit of minor adjustments to it. So if I were to make this side equal 0, okay, subtract 2, I'd subtract 2, and when I do that, I end up getting that 0 equals 3x plus 5. Notice 3x plus 5, 3x plus 5. That is the exact same thing, right? So the only difference is that this one has a y, and this one has a 0. Okay, now this might be a stretch for some of you guys to see the comparison here, but we just talked about when we were dealing with our x-intercepts, okay, when I was dealing with my x-intercepts, we discussed that every x-intercept we found, there was one that was 2, 0, 1 half 0, negative 1, 0. All of our x-intercepts had a y value of 0, right? Okay? And the connection is that this is a y, and now all of a sudden that y became a 0. Okay? Y and 0 are interchangeable in this. What I'm telling you guys is every linear equation that we were finding last time every linear equation can be written in this form here. Every linear equation that we were solving for, every time we found an answer, that answer that you found was the x-intercept of that line. Even the equations that were like 53 equals 2 times x plus 3 minus 4 times 2x minus 5, even that equation can be written in this form here with my y equals. Every equation that you guys are solving, the x value that you're finding when you're solving for that x is our y-intercept. And I can show you guys this real quick. 53 equals 2x plus 6 minus 8x plus 20. Okay, 53, 2x and negative 8x gives me negative 6x. 6 and 20 gives me a positive 6. Okay, I need to get 53 to the other side, so I subtract 53 over. I get 0 equals negative 6x minus 27. Okay, and now this becomes y equals negative 6x minus 27. Now we've got our line. This right here, we created that from solving for an x-intercept. Okay? So that's just kind of a little bit of tie-in. You don't really need to know any of that information other than I want you guys to know when you're solving equations, you are finding x-intercepts. Okay? Anytime you're solving an equation, you are finding an x-intercept. Okay? So, tie-in from last class. Now, taking that information that we learned on that last slide, not the last slide, the slide before that, 3 slides before that. It was the first slide that we started talking about when we were making that investigation. Okay, we said that our x-intercepts, 2, 0, 1 half 0, negative 1, 0. Okay, we said that all of those x-intercepts had a y value of 0. Okay, so when you are trying to find my x-intercept, when I'm trying to find the x-intercept, our rule that we're going to use is we need to set our y value, or just our y, And what do we want to set our y equal to when we are dealing with x-intercepts? Well, we want to set our y value equal to 0. Okay? Then this one took us a little bit longer to figure out, but we went through our y-intercepts, and we had y-intercepts of 0, -3, I think we had 0, 1, I think we had 0, -2, okay, those were all y-intercepts. And we ended up finding a similar pattern, right? We said for our y-intercepts, it looks like all of our x values are equaling 0. So when we are trying to find our y-intercept, we need to set our x value equal to, whoops, you can't even see that, equal to 0. Okay, and that is the pattern that we will use to find x-intercepts. That's the pattern we will use to find y-intercepts. And the best part is that in Algebra 2 this year, you guys are going to learn a lot of different functions. Right now, we're focusing on linear functions. That's stuff you guys have done before. We're going to talk about quadratic functions. That's your parabolas. We're going to talk about absolute value functions. You guys haven't talked about that before. Square root functions, cube root functions, exponential functions, logarithmic functions, rational functions. We're going to cover all of those functions. But guys, this slide right here might be the most important information that you guys are going to need, because I'm going to ask you to find the x-intercepts of all of those functions. And you need to remember that if I want to find the x-intercept, I set y equal to 0. And you need to remember, if I want to find the y-intercept, I set x equal to 0. This is going to be on every single test from now on. How do I find the x-intercept? Set y equal to 0. How do I find the y-intercept? Set my x equal to 0. Okay? This will be on every test. You have to remember this slide. This slide is super important. Now let's apply that knowledge. Okay? So I have given you guys that linear equation that we were looking at. Y equals 3x plus 5. Y equals 3x plus 5. When you guys solve these problems, you're going to write that equation down, and then there's going to be two things you need to do. You need to find the x-intercept, and you need to find the y-intercept. Okay? We need to remember, to find the x-intercept, I need to set y equal to 0. So I'm going to take my equation up here, but instead of having a y, I'm going to have a 0. So this will become 0 equals 3x plus 5. Now all I need to do is solve. So I've got 0 equals 3x plus 5. Now I just need to solve this equation. Minus 5 minus 5. -5 equals 3 times x. Trying to solve for x, so I would need to divide by 3. Divide by 3. And I find that x equals -5/3. My x-intercept is -5/3. Not my final answer, though, because we want to write these as points. So -5/3 for my x, and then we had a 0 for my y. So my x-intercept of this equation up here, the x-intercept of this equation, is going to be -5/3, 0. Then I'm going to switch. I'm going to find my y-intercept. What do I need to remember about the y-intercept? Well, y-intercept, we set x equal to 0. Okay? So up here, I'm going to write this equation down, but instead of an x, I'm going to have a 0. So this will become y equals 3 times 0 plus 5. And now I just need to simplify this one, because I don't even have to solve. Y is already by itself, right? Normally we would solve for y. Y is already solved, so I just need to simplify. What's 3 times 0? Well, 3 times 0 is 0. 0 plus 5, oh, well, that's just 5. So y equals 5 is my y-intercept. Okay? So, I'm going to write it as a point for my final answer. I know my y value is 5. What is my x value? Well, my x value is 0. So 0, 5 is my y-intercept. Okay? Next example, I've got f of x equals 1/2 x plus 6. Okay? F of x. This is function notation. We are going to talk about that when we get to Unit 2, but I did want to show it to you guys here because it should be familiar. F of x is actually interchangeable with something. Okay, and f of x is the same thing as y. So if you guys ever see an f of x written down, just remember that this is really just a y equals 1/2 x plus 6. Y equals 1/2 x plus 6. Okay, so I need to find my x-intercept. Find my x-intercept. Well, I'm just going to set my y value. Whoops, I don't need a y there. I'm going to set my y value equal to 0. So I get 0 equals 1/2 x plus 6. Okay, I need to solve for x. So I can subtract 6. Okay, gives me a -6 equals 1/2 x. A lot of you guys would probably divide both sides by 2. Divide both sides by 1/2. I prefer to multiply by the reciprocal. Multiply by 2 over 1. So I'm going to multiply by 2 on this side. And I end up with -12 equals x. Okay, so my x-intercept is -12. Remember, I want my answer as a point, though. So I go -12, 0. Okay, y-intercept, I want to set my x value equal to 0. So I will have y equals 1/2 times, I've got a 0 in there for my x, plus 6. Okay, 0 times 1/2 is just a 0. So really, this is just a y equals 6. I really want you guys to write this step every time. Sometimes you guys will work through these and you'll be like, oh, yeah, I already know the y-intercept is 6. Still show this step because I want you guys to remember that for a y-intercept, we set x equal to 0. Okay? So final answer for this, x is 0, but my y is 6. Okay? One more example. Okay, I've got 4x minus 3y equals 12. Okay, this one looks a little bit different, but just remember your rules. Finding your x-intercept, set y equal to 0. Finding your y-intercept, set x equal to 0. Pause the video, try it on your own. Okay, so for my x-intercept, I'm going to have 4x minus 3 times 0. And plug that in for my y there. Equals 12. -3 times 0, that's just gone. So I've got 4x equals 12. Divide both sides by 4. And I find that x equals 3. So my x-intercept would be 3, 0. Okay, vice versa, y-intercept, we want to set x equal to 0. So I go 4 times 0 minus 3y equals 12. Okay, 4 times 0 is gone. Okay, that's just 0. So I've got a -3y, don't forget the negative, equals 12. Need to solve for y, divide by -3, divide by -3. I end up with y equals -4. Okay, so my y-intercept is -4, so I'm going to go 0 for my x, -4 for my y. And there's my y-intercept. Okay, so that's pretty much all you guys need to know about finding your x and y intercepts. One thing I would add with it is you guys could, this might happen, it might throw you off. Say you had a line that ran like this, okay? What's its x-intercept? Well, the x-intercept is right there. My x-intercept would be 0, 0, right? What's my y-intercept? Oh, well, it also crosses right there, so my y-intercept is also 0, 0. Okay, so basically I just want to show you guys that it is possible that your x and y intercept could be the same thing. It's only possible, though, if it is at 0, 0. That's the only time that could happen. Okay?